Hello everyone and welcome to this new video, which will be a somewhat theoretical following of the previous tutorial about extrusion. First, we will discover what normals are. I'm sorry this is going to be 100% theoretical at first, but stay with us. The concept of normal is fundamental when you start to do serious things in 3D, so it's a good thing you know what they are, because afterwards it will allow me to explain new tools that are based on normals. By the way, after theory, we will directly practice by using normals to correctly redo the extrusion of the magazine base. Let's start rough. What is a normal? A normal looks like this. In this drawing, it is the red arrows placed on the faces. More precisely, these arrows are vectors. So what is a vector? A vector is a mathematical object, also represented here by a red arrow. A vector is defined by two parameters. The first parameter is its origin, and the second parameter is the direction, which can be defined either in a polar way, i.e. by an angle, or in a Cartesian way, with a point placed with coordinates. If I go back to the diagram of the normals, we notice that, as a vector, the particularity of a normal is that its origin is the center of a polygon. And also, a normal has a polar direction of 90 degrees. So a normal is always perpendicular to its face, and I say its face because in fact, a normal is always relative to a face. There are as many normals as there are faces. And besides, I'm talking about normals, but in fact we should say faces normals. When editing a polygonal object, Blender allows us to display each face's normals. To show you, let's create a sphere. Then switch to Edit mode with the Tab key, and in the Overlay menu, I can tell Blender to show me the face's normals, and I can increase their size here. And now blue hairs appears on the model, but it's not hairs, it's the normals of each face of the sphere. And if we look closely, each normal's origin is placed at the center of its face and is oriented perpendicular to it. Okay, but then, what can normals be used for? There are many applications. If you play video games, you may have already heard of normal maps, for example. But basically, the normals allow us to choose which is the visible side of a face. Because indeed in 3D, a face is only visible from one side. Blender, like most 3D modeling tools, is able to display both sides of faces, as it is more convenient to model. But you may have noticed in other 3D softwares, such as slicers, very often the faces only appear on one side. So to illustrate this, I'm going to create a plane, which is actually a single four-sided face, and in the 3D viewport display setting, we can enable an option called backface culling. And now, we can see that one side of the face is clearly visible, and the other side is perfectly invisible. And if I set a side view, isolate the object so we can see better, and switch to Edit mode to display normals, we can see that the normal is positioned on the visible side of the face. There, with other objects displayed, we can clearly see that the object is transparent from below, and from above, on the side, where the normal is located, the face is visible. So why is that? Well, it's simply because the 3D engine uses the normal as a mathematical property to calculate visibility, aspect, shading, light reflection of each face. It can even create relief using normal maps. So the engine needs the position and orientation of the normals to display 3D objects. Another example that may speak to you, again, if you play video games, you may have already encountered this situation, where a collision bug allows you to go inside something like a wall or a rock. And inside this object, you can see through it, the object becomes completely transparent. Well, indeed, on this side of the geometry, no face's visibility are calculated by the engine because the normals are all on the other side. So when we are modeling objects, we make sure that all the normals are well oriented outwards, so that all the faces will be visible from the outside of the object. On the other hand, if we model an environment, an envelope, like a room for example, if I want the walls to be visible when we are inside this room, we must orient the normals towards the interior of the object. For this, we can flip normals. Blender has a lot of tools to edit normals that can be found in a menu displayed with Alt+N shortcut. And in this menu, I can flip normal. So now, the room, or rather the faces of the room, are invisible when I'm facing behind them. But if I stand inside the object, I can see all the faces since they have all their normals facing inward. I hope this isn't too abstract for you. I'll show you another example that concerns us directly when we do 3D printing. Almost everyone who does 3D printing has encountered problems with misoriented normals. For example, if I edit this rock, I select a part of the geometry, and with Alt-N shortcut, I flip the selected face's normals. It gives us this strange effect, a little bit like a hole, because I can see the faces only if my view is facing their normals. Then I export this file in STL to print it, and I open it in a slicer. So this time, the faces whose normals are flipped are not transparent. With Chitabox, they are displayed with a dark blue. And if we slice, we can see that the faces are simply ignored by the slicer. This is going to be problematic. The rock won't be printed correctly. Blender has a tool that allows us to make all normals uniform, that is to say, to orient all normals either inward or outward from the volume of an object. So I go into Edit mode, I select all the rock faces with the A key, I display Normals menu with Alt-N key, and here we find this tool called Recalculate Outside, and voila, all the normals are now facing outwards, and our object has again, we can say, a kind of consistency, and it will be able to be printed without any problem. So that's one of the fundamental functions of normals, being used by the engine to calculate faces visibility. And that's it for the theory. Let's go back to the Bolter's magazine. So how normals can be useful for what we want to do. Remember in last tuto we extruded 4 faces of the base to create a thickness. We used a scale to extrude faces in several directions and finished the work by moving some edges. It would have been faster if we could extrude each faces in the right direction directly. We have seen that one of normals' properties is to be perpendicular to each of their faces. And so we can wonder if, by chance, it would be possible to use normals as a reference, as a direction to extrude several faces perpendicularly. Of course we can do that. So I select the 4 faces like we did, but this time in the face menu, we don't choose the Extrude Faces tool, but extrude along normals, and I insist on normals with an S, because that will extrude the faces according the direction of each normals independently. And now, we no longer extrude our faces along a global, local, or other axis, but using the direction of each face normal, that is to say in a perpendicular direction. However, we still have a few issues. It extruded much more in width than in depth, and we have this kind of strange rotation. It's a bit the same kind of problem we had in the previous tutorial. So I'm going to explain to you how to correct all that by going back to object mode, and let's look at the transformation values. We see that the XYZ scale values are different. It means that the object has been deformed with non-uniform scale. This is indeed what we did in the very first video about the bolt gun. We started from a cube and we deformed it along X, Y, and Z global axis to match the volume to the dimensions of the magazine. And what you need to know is that the deformation created by a scale affects the object, but also the data. So when I extrude faces along their normals, the faces we extruded toward Y-axis were not moved by 100%, but by 0.080. And the faces that have been moved in the direction of X have been moved by 0.336. And the imbalance of this scale also creates an imbalance during the extrusion. If the object had been scaled uniformly, with 3 identical values here, we would not have made the difference, but there, this imbalance shows us that the volume of the object as it looks here is not its true volume. it is deformed by a scale that is borrowing us. So we will have to reset this scale, i.e. make all these values equal, back to a uniform scale of 1, while keeping the object as it currently is, because its dimensions are like we want them to be. We don't want to change it. How to do that? If we set all the scale values to 1 like that, obviously the object will return to its original scale, and that's not what we intend to do at all. What needs to be done is to recalculate a new position value for each point of the geometry. So these new positions will no longer be the result of a deformation, but absolute positions, without the influence of a scale, whose values can therefore be equal to 1 for all axes again. This operation is called applying a transformation. And fortunately, there is a tool that makes all these very complex maths automatically. First of all, we will reload the original file to cancel this extrusion. So, we still have different scale values here, and to correct that, we go to the Object menu, then Apply submenu, and we choose Apply Scale, because we can apply any type of transformation, but here we just want to apply the scale. And look, the scale values have changed to 1, but my object remains the same. On the other hand, that means that the object will no longer be able to return to its original scale, as we did earlier when I set all the values to 1. Now, the object original scale is the one we can see. So now that we have applied the scale, we will be able to redo our extrusion along the normals. And there, finally we meet perfection. So I'm going to start again with a front view. I extrude the faces again along normals, and with the help of the drawing, I can place the extruded faces exactly where they are supposed to be, and voila, we have a perfectly extruded magazine base. So, it was a bit long, but you'll find that most of the time, you won't need to do all that. If you have a non-uniform scale problem when modeling, well, you will apply the scale once and for all. You won't have to do it again later, except if you scale your object again, but it's pretty quick to apply this transformation. Finally, we'll just talk about the normal axis orientation of a face or an edge. In edit mode, if you want to move a face in the direction of its normal, as we did with the extrusion along the normals, but for a simple movement, how can we do that? We saw in the previous tutorial that the local orientation was not necessarily a good solution. But on the other hand, we have the normal orientation, which we didn't talk about until now. Because if you remember the tutorial about axis orientation, I told you we won't talk about this axis orientation until we know what normals are. Well, it's now done. So you guess that with normal orientation, the gizmo will be aligned to normals. And there we have at least one of the axes of the gizmo perfectly orthogonal to the face. And here we are, we will be able to adjust faces' position with flexibility, without losing the perpendicularity of the faces. It is an orientation mode that we will use a lot when editing polygons. That's all for this video. Thank you for watching it, and I'll see you very soon.